All right, guys, today's lesson is all about multiplying decimals. And you did a great job at multiplying a decimal times a whole number. And multiplying two decimals is just as easy as multiplying a decimal and a whole number. The key to remember is that however many digits are after the decimal in the answer is the same as how many are after the decimal in the problem. So this time we have two numbers that are decimals. How many digits are after the decimal with this number? 1. How many digits are after the decimal in this number, 9 and 8/10? 1. That tells me two digits will be after the decimal. Let me get rid of that box. Two digits in the answer. And let me show you, that's some pretty bad handwriting, what I mean. I'm going to use the standard algorithm to solve it. So while I'm solving it, I can really just ignore the decimals and I can line up my digits. So for 41, if I take the decimal out, and this number becomes 98, and now I multiply. 8 times 1, 8 times 4, put in my 0, 9 times 1, 9 times 4. Now I'm going to add it up, and I get 8, 11, carry my 1, 10, 4. So I have my answer of 4,18. But I have to remember to go back and put my decimal where it should go. So if I look back at the problem, there's one digit and one digit together. That's two digits. So I'm going to go and put my decimal in where there are two digits. It just so happens to be the same digits. That's a crazy coincidence. But two digits are after the decimal in my answer. Now let's check to see if this answer is a reasonable answer with our estimation. I would take 4 and 1/10 and make it a 4 if I'm rounding, and I would take 4 and 8/10 and turn it into a 10. And what's 4 times 10? 40, which is super close. Therefore, 40 and 18/100 is an extremely reasonable answer, and we probably got it right. So the key to remember is you'll have the same amount of digits after the decimal in your answer that are in the problem. Let's look at some problems here. Let's pause the video. Well, we'll do one together and then we'll pause. And here I want you to check to see if your answer is reasonable with estimation again. This time I'm going to use the area model, but you can use whichever multiplication strategy works best for you. I have two digits, so I need two boxes. 3 has a digit, so I put a 0 because it has a digit after it, so I know it'll have 1 0 after it. And then 8 just goes here. Because I am completely ignoring the decimal, and I'm acting like this number is 38. Here, I'm acting like this one is just 75. Again, I only have two digits, so we have a 70 and a 5. And when I multiply 7 times 3, that's 21, but I need to put my two zeros in my answer. For this box, 8 times 7, because I ignore the 0, and that's 56, and then I put my 0 back on my answer. Here is 15 with the 0, and here is 40. Now when I add all of these up, 2100, 560, 150, 40. I get a 0 here, a 15 here, 5, 6, 7, 8 here, and 2. Now I need to figure out where my decimal goes. So I'm going to go back to the problem. I'm looking at both numbers. How many digits are after the decimal here? 1. How many digits are after the decimal here? 1. That means 2 altogether. So I need two numbers after my decimal again. So my decimal is going to go right there. And my answer is 28 and 50 hundredths. Or you could say 28 and 5/10. since we could add as many zeros as we wanted to in the answer, and it doesn't change. This 5 will always be just a 5. All right, so let's estimate and see if this is a reasonable answer. 3 and 8/10 I'm going to estimate to 4. And 7 and 5/10 I guess I should just estimate to 8. What is 4 times 8? 32, which is not too far off from 28. So I'm going to think, okay, this went up quite a bit. 7.5 turned into 8. So I'm thinking this is still a pretty reasonable answer. If I really wanted to, I could go back and double check my work, and that's what I'm going to do. 2100, 56, 560, 150, and 40. 0, 11, 15, carry my 1, 7, 8, and 2. Yeah, it checks up. So go ahead and pause the video. Remember, ignore the decimal and just think of this problem right here as 91 times 84. But then go back and put your decimal in where it should go. You determine where it should go because you look at the problem and you see how many digits are after each decimal place in the problem. Go ahead and pause it, and then we can check our work. All right, I'm assuming that you paused it and you tried these problems, and now let's check the work. Let's do the partial product strategy for this one. This is the one I always get messed up on, so hopefully I don't mess it up this time. 91 times 84. So 4 times 1 is 4, and 4 times 90 is 360. 80 times 1 is 80, and 80 times 90, 80 times 90, well, that's 72 with 2 zeros, 0, 0, 2, 7. And I add these up. My 4 is off to the side, but I know it's supposed to be over here with this over here. 14, carry my 1, 6, 7. So the answer I got was 7,000. Whoop, I didn't mean to put that there. I'm going to delete it. Start over. 7,644. And now I need to put my decimal in, so I go back and I see 1 digit here, and I see 2 digits here. So that's 1, 2, 3 digits after my decimal. That means my decimal is going to go all the way up here, and the answer is 7 and 644 thousandths. Now let's estimate to see if this is reasonable, because you know how I seem to mess this up before. All right, so 91 hundredths, I'm going to estimate to 1, and 8 and 4 tenths, I'm going to estimate to 8, and 8 times 1 is 8, which is super close to the answer we got. So this answer makes a lot of sense. All right, I'll move this out of the way because it is a little close to my work. And let's try this next one. 7 and 3 tenths times 5 and 8 tenths. Remember, you ignore the decimal in the beginning. I'm going back to the standard algorithm for this one. And I'm just thinking about 73 times 58. This is 24, carrying my 2. That would be 58. Put my 0 down. 15, carry my 1. 36. Add it up. 8, 9, 10, 11, 12, 13, 12, 4. So I get 4,234. But I can't forget my decimal. How many digits are after the decimals in the problem? There's 1, there's 2. So that means my decimal will go here. 42 and 34 hundredths. Let's estimate and check. 7 and 3 tenths is about 7. 5, oh, it's not letting me write. Gotta extend it. It's getting kind of small. Here we go. Where am I at? 5 and 8/10 is pretty close to 6. And together, these would be 42, which look at that. Our answer, I can't see there we go. My answer is super close to 42, so it makes sense. All right, let's go over here. And 52 times 45. My cursor disappeared. I can't see it. There we go. And whoops. Sorry. Get rid of that. So now we can multiply. Whatever. And I'm going to use the standard algorithm again. 5 times 2 is, where's my cursor at? There it is. 5 times 2 is 10. Carry my 1. That would be 26. Put down my 0. And that would be 8 and 20. And then when I add it up, we get 0, 14, 3, 2. And I see that there are 3 digits after my decimal. I can't see where my cursor is. There it is. So my decimal should go right there, because up here, where am I at? There's 1 digit after the decimal. This is getting bad. And 2 digits after the decimal here. So altogether, we should have 3 digits after the decimal. If we were to estimate, let's see. I have no idea where my pen's at. Here it is. 5 and 2/10 estimates to 5. And 0 and 45/100. Man, that's super close to 1. But it would actually round to 0, right? Whoop. And we know 0 times 5 is 0, which 0 is close to the number 2, which is the whole number in our answer. So this answer makes sense. Let me see if I can circle it without ruining everything. There, no, not too good. So our answer should be 2 and 340 thousandths for that problem. All right, so here we have a word problem. And once again, we will be multiplying 2 decimals, and we want to ignore the decimals, multiply the numbers, and then put our decimal back in and check to see if it's a reasonable answer. So a giraffe can run up to 46 and 5/10 feet per second. How far could a giraffe run in 1 8/10 seconds? I really didn't know that giraffes could run that quickly. All right, not to get distracted, how do I know that this is a multiplication problem? Well, I see up here that it's telling me, I don't think my pen will go up that far, that a giraffe can run up to 46.5 feet per second. And these per seconds, that means in 1 second. So 46 and 5/10 in 1 second. Second, wow. That's crazy fast, I think. And how far could a giraffe run in 1 8/10 seconds? So we are not just looking at 1 second, but increasing it. So we can multiply these two numbers to figure out how far a giraffe would run in 1 8/10 seconds. Again, I'm just ignoring the decimal. So 46 and 5/10, I'm going to think of it as 465. 1 8/10, I'm going to think of it as 18. And I'm going to use the area model for this one. I haven't used it in a while. So my first number has 3 digits. That means I need to split it into 3 sections. This would be 465. And this one is still just 2, so that's a 10 and an 8. And now I can multiply. 4 times 1 is 4, but I have 1, 2, 3 zeros. 1, 2, 3. Here I can ignore the zeros and do 6 times 1 is 6, but then I put them back in. This is 5 times 10, which I know is 50. Over here, ignoring the zeros, 8 times 4 is 32. Put them back in. 6 times 8 is 48, but don't forget my 1 0 up there. and 5 times 8 is 40. So now I need to add these numbers up. 4,000, trying to line them up as I write them, 600, 50, 3,200, 480, and 40. I bet it wants me to extend the page. And here we go. Adding all those up, that's 0, 12, 17, carry my 1, 9, 13, carry my 1, 8. So I got 8,370. But I need to go back to the problem to figure out where will my decimal go in this answer. Well, this only has 1 digit after the decimal, and this number has 1 digit after the decimal. So that means altogether there should be 2 digits after the decimal. So our answer is 83 70/100 feet in 1.8 seconds. Let's make sure this is reasonable. Estimation, 46 5/10 is about 47, which is really close to 50 if we think about it. And then 1 8/10. Oh, get to hear Mr. Beck make an announcement. 1 8/10 is estimated to 2. So I could say 47 times 2 is 94, which is pretty close to what we got. Or I could do 50 times 2, which would give me 100, which of course is going to be farther from our answer because we estimated it to a farther number from the actual number, remember? So we got 94 as an estimation. Is that reasonable if we got 83 7/10? I think it is. I think it's a pretty reasonable answer because 46 rounded to 47, which is a large amount. 47 is a larger number, and then 2 is a smaller number, and we multiplied correctly, right? 14 and 9, yep. So it's not too far off. I think it's pretty reasonable. So our answer here makes sense. One more. 1 mile is approximately 1 6/10 kilometers. How many kilometers is 2.5 miles? Once again, check with estimation. So how do I know this is a multiplication problem? Well, it tells me that 1 mile is equal to 1 6/10 kilometers. And then it wants to know how many kilometers is equal to 2.5 miles. So we went from 1 to 2.5. I want to see how many kilometers would go into 2.5 miles, so I have to multiply it to get my answer. And here I'm going to ignore it and act like it's a 16. Ignore the decimal, act like it's a 25. Let's use the partial product for this one. 5 times 6 is 30. 5 times 10 is 50. 20 times 6 is 120. 20 times 10, I need to see this visual, is 200. And now when I add these up, I get 7, 10, carry 400. 400, that's a nice number. So I need to go back and figure out where my decimal should go. In 1 6/10, there's 1 digit after the decimal. In 2 5/10, there's 1 digit. So together, that's 2 digits. So my answer is 4. 4 kilometers in 2.5 miles. Let's make sure this answer makes sense with estimation. All right, so 1 6/10 rounds to 2, and 2 5/10 rounds to 3, and 2 times 3 is 6, which is more than 4. But this number increased, and this number increased, so it makes complete sense that our estimation would be higher than our actual number. So now we know there's approximately 4 miles or 4 kilometers in 2.5 miles. There we go, got that right. All right, so your assignment is attached to this. Once again, I would like you to show your work on a piece of paper, take a picture of it, and upload your work to your attachment to your assignment. Remember, I posted a video under the category Help Videos. It's called Pictures, and it shows you exactly how to take a picture on your Chromebook and upload it to attach to your assignment. If you have a different device and you need help, just send me an email and I'll try to help you work through it so you can add a picture too. All right? Good luck.